Okay, when you're solving any energy problem, you want to locate two events in the problem. So we have an arrow, it's being launched from a bow with velocity 2 meters per second from a castle tower that is 5 meters tall. So that's event one. It's going to strike a knight on a horse that is 2 meters tall on the ground below. That's event two. So when we construct our givens, we're going to keep in mind that, well, first we'll actually draw a picture. So we'll draw the castle. That's the ground. Here's the knight. And the arrow is being launched from the tower and hits the knight. Now, when we're dealing with energy, we don't have to worry about angles. We don't have to worry about x and y directions because energy is a scalar. So the energy doesn't depend on directions. So I'm going to make this event 1, the top of the tower. And when it strikes the knight, that's event 2. So in event 1, we have an initial velocity, or event 1 velocity. That's 2 meters per second. And I'm actually going to erase that. The bar, we'll just make this the magnitude of the velocity. So whenever we talk about velocity, when we talk about energy, we don't really have to worry about the direction because that gets removed anyway. When we square the value, the direction disappears. Now you'll notice that we don't know what the mass of the arrow is. So if we don't know the mass of something, we're going to replace it with the letter m. And what else do we know? We know that the height from the ground, so when we're dealing with height, particularly with potential energy, we have to always be with respect to something. So in this case, we're with respect to the ground. We could actually make it respect to the knight's head if we wanted to, but we're going to make it with respect to the ground. So that height is 5 meters. And then for event 2, we have, we're trying to figure out what the velocity 2 is. Let's see if I can erase this. Trying to figure out what velocity 2 is, so that's our unknown. And then our height at that event is 2 meters. And that's all we know. So this is a conservation of energy problem. We know that because there's 2 events and we're trying to figure out what is happening to the arrow as it's flying through the air, and it's going to be accelerating. So we're going to use conservation of energy to solve this problem. Use conservation of energy. And that basically says that the total energy at position 1 has to be the same as the total energy at position 2. We're neglecting energy loss due to friction in this example. There's no drag. So the total energy at position 1 is made up of 2 types of energy. There's kinetic energy at position 1, and there's potential energy at position 1. Similarly, at position 2, we have kinetic energy. Even if any of these are ever 0 at any time, and in this case they're not, but if there's ever a situation where each of these values is 0, I still want you to write that there's an EG. I still want you to write EG2 here, even though the value might be 0. So next thing we're going to do is we're going to replace these values with their formula. So we have m v1 squared plus mg h1 equals half mv2 squared plus sorry, my computer's slowing down. All right, so there's an m in every term, so that means we can divide by m. And this makes sense because mass, we know that it doesn't matter what the mass is. If we throw it up, it will accelerate down at the same rate. So as long as the masses have the same velocities, they will have the same velocities throughout the arc. So now we're going to replace the values that we know. So let's get rid of some of this. And then I'm going to actually move this up. What's going on here? Right, anyway, oh. That is very unlegible. Okay, so anyway, I'm just going to replace the values here. So this is going to be 2 squared plus 9.8 times 5 plus half v2 squared, which we don't know, plus 9.8 times 2, that's the height. And then you're going to, oh, this is equal, not plus. And then you're going to solve for this. So this is approximately 2. This is approximately 50. This is a half v2 squared. This is approximately 20. And so if we bring everything to the left side, so this will be 52 minus 20, which is 32. And then we're going to multiply that by 2. So that becomes 64. 52, 32, yep. And then if we take the square root of 64, that's 8. So the arrow will strike the knight's head at 8 meters per second down.